Hi all the students, today we are going to study error detection using the checksum method, right? So this is another method of detecting errors at the receiver's side. Now checksum method, first of all we'll see how this method works at the sender side, and then we'll see the receiver's side also, just like we saw the CRC method at both the sender and the receiver side, right? So we'll begin with the sender because it is the sender who initiates the transmission. So the first, we basically divide this method into 3 or 4 steps, wherein in the first step, you break the original message into k blocks with n bits in each blocks. So say for example you have m number of bits. Those m number of bits will be divided into k blocks where each of the block will have n bits. So say for example you have a message in which there are 5 blocks and each block is having 4 bits. So there are 4 bits in in each of the block, wherein the total number of blocks are 5. So that means you have total how many bits? In the original message, there are total 20 bits in the original message. And how have you divided those 20 bits? Into 5 blocks of 4 bits each. So this is the first step. Then you will sum all the k blocks, right? You will do the addition or sum of all the k blocks. Then if there is any carry to the sum, then you will add it to the sum. And then after that, you will do the ones complement to that sum. You will do the ones complement to the sum. So if I take an example, say for example, this is the original frame that has to be sent. So what will you do? Now there are total 1, 2, 3, 4, 5, 6, 7, 8. As you can see, there are 32 bits in total in the original message that has to be transmitted. So how can you divide it into k blocks of n bits each? You can divide it into 4 blocks of basically 8 bits each. So each block has 1, 2, 3, 4, 5, 6, 7, 8. And you have 4 such blocks. That means in total you have 32 bits. So how did you divide those 32 bits? By dividing them into 4 blocks of 8 bits each, right? This is the first step. Now as per the second step, you have to sum all the k blocks. So these are the 4 blocks. You have to sum all of these 4 blocks. So when you perform the addition of these 4 blocks, what you get in result is this. 1 0 0 1 0 0 1 1. But now you can see that we had divided the 4 blocks into 8 bits each. But the result of addition is giving you a total of 10 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means there is a carry. And as the third step says, add the carry to sum if any. So this carry will be added to this sum. So after I add 1 0 to 0 0 1 0 0 1 1 to this is the actual 8 bits and this is the carry. So I will add this carry to these 8 bits. So what do I get in result? 0 0 1 0 0 1 0 1. So now I have exactly 8 bits. 1 2 3 4 5 6 7 8. So this is the result of the addition of these 4 blocks with 8 bits each, and the result must also have 8 bits only. So now I have 8 bits. 1 2 3 4 5 6 7 8. So whenever there is a carry, that means you have more than the n bits, you can add those remaining bits of the carry to those n bits and then you get the result, right? So here I had 10 bits and I wanted 8 bits because each block was of 8 bits. So the remaining 2 bits were added to these 8 bits and as a result I got this. Right now, so now in total I have 8 bits. So this is the result of addition of all the 4 blocks. So this is how you will add k blocks of n bits each. Now the result of addition, as you know, is this. You have to take the ones complement of this result of addition. So ones complement, as you know, is the opposite. So if it is a 1, it will become 0. If it is a 0, it will become a 1. So that means the ones complement of this result will give me 1 1 0 1 1 0 1 0. So this is what you call the checksum. So that means after taking out the ones complement of the result of addition of the k blocks of n bits each, what I get is the checksum. So this is my checksum. Now the original data along with the checksum is transmitted to the receiver. That means this is the original data that we are talking about, and the checksum will be appended with this original data. You will append the checksum at the end of this original data, and then this original data appended with the checksum is transmitted to the receiver. Now what happens at the receiver side? The received data unit is divided into segments of 8 bits again, right? So that you know how you will do. And all segments along with the checksum are added. So basically all segments along with the checksum are added. So I already know the result of addition of these 4 segments, right? Receiver does not know. Receiver will do it all over again. But here, since we are doing the calculation at both the sender and the receiver side, so we already know the result of the 8 bits of these 4 segments. So I will not calculate it again. I already know the sum of these 4 segments of 8 bits each, and the sum that I got is 001 00 101. So this was the result of addition that I already got. So I'll simply put it here, plus the checksum value, because the data is now appended with the checksum. So that means to the result you will have to add the checksum value also, which is basically nothing but the ones complement of the result of addition. So I add the checksum to this to the sum of all segments. So this is the sum of all the segments, and this is the checksum. So after adding the checksum to the sum of all the segments, what I get is this. That means 1 2 3 4 5 6 7 8. It is exactly 8 bits. So 1, I have got basically 8 1 bits. After performing the addition of the sum of all segments and the checksum value, I will again take out the ones complement of the result. So the ones complement of this result gives me 8 zeros. So if it gives me all zeros, then the receiver gets to know that the transmission is correct. So if there are all zeros in the ones complement of the result of the sum of all segments and the checksum value, then the transmission is correct, else it is incorrect. So this is how you can detect the presence or absence of errors in the data transmitted by the sender at the receiver side using the checksum method.